parts of the circumference, you call that line.
This call is now being recorded. This call is now taking notes.
So you call that line a chord. So let us assume that we have a line coming from here. Oh, too big. We have a line coming from here down to these other parts. You can see that line there at the the bottom part of the circle. Any line that can touch the circle at 2 points on each circumference, thereby dividing the circle into 2 parts, that line is referred to as a chord. So you see this line here, you call it a chord. That is what you call the line there, a chord. So the chord is any line that can touch the circle at 2 points on each circumference. This is a very wide topic. It takes us to sectors, segments, and then before we get into the circle theorem itself, which the first theorem would be the chord properties. Then you also have angles at the center, equals twice the angles at the circumference, and so on and so forth. So, but we're starting from the beginning of the whole circle stuff, which would lead us to arcs, sectors, segments. So that was where we'll have to start from today. So remember, like we just said, that any line that can touch the body of the circle at 2 points, that is, remember, the body of the circle is called the circumference. Any line that can touch the body of the circle at 2 points, that line is referred to as a chord. A chord. So definitely, as is seen, we are starting from the majoration part of circles. This is the majoration part of circles. We actually haven't gotten into the theorems itself. And it's important to have to start from this part so that it gives you an insight of the other things you have to do up front. So this is the chord, like we've said. Now we'll come back to, remember, body of the circle is the circumference. Then any line that touches the circle at 2 points on the circumference is a chord. Now we will proceed to another part. Let's draw another circle here. This circle is looking like an egg. Okay, so let's say this is another circle. And then again, let's call this the center of the circle. Put the dots there. Any line that cuts through the center of the circle and thereby cuts the circle into 2 equal parts. Remember, that line cutting the circle into 2 equal parts has to pass through the center, definitely. And if it passes through the center, it has to meet be touching the circle at 2 points on each circumference. Now that line is called a diameter. You're very familiar with diameters. So a diameter is a type of chord. Remember, this is a chord. A chord is any line that can touch the circle, the body of the circle, at 2 different points. It must have to be 2 different points before you call it a chord. It has to be 2 different points. Now look at this other one you call a diameter. You would see that this diameter, this line, is still touching the circle at 2 points on the circumference, you can see. Let's call this point A and call this point B. So it's still touching the circle at 2 points, at point A and point B, but it is passing through the center. That is to say that a diameter is a particular type of chord. because a chord is any line that can touch the body of the circle at 2 points, the circumference of the circle at 2 points. And now the diameter is also touching the circumference of the circle at 2 points, but it passes through the center of the circle. So the diameter is a particular type of chord that passes through the center of the circle, thereby dividing the circle into two equal parts. That makes the diameter a type of chord. It's just like saying human beings, humans. Humans is a general name for us living here on earth. That is how chord is. Chord is a general name for any line that can touch the circumference of the circle at two parts. Then now, when you're being specific, instead of just saying humans, you're referring to a particular type of human. You say man. Or if you're referring to the females, you say woman. In that same vein, that is how diameter is now a particular type of chord. But just like when you said humans is a general name, which is chord is a general name for any line that touches the circumference at 2 points. Now, for the diameter is now a particular type of chord that must pass through the center of the circle and touches the thereby dividing the circle into two different parts. So the diameter is now like when you are referring to man or woman, you are now being specific. So the diameter is a chord, but it is a type of chord that passes through the center of the circle, because obviously you can see it's touching the circumference of the circle at 2 points. So now that is the diameter. Then you already know about the radius of a circle. The radius of the circle doesn't touch the circle, the body of the circle, the circumference of the circle at 2 points. It only touches the circumference of the circle at 1 point and then ends at the center of the circle. So this is an illustration of the radius. You see the radius here would come through from the center. Mark this as the center. The radius comes from 1 point on the circumference and stops at the center. So this is now a radius. So now question, would you call a radius a chord? Winner, this question is for you. Would you call a radius a chord? Would you say a radius is a chord? Winner. Okay, winner isn't responsive. Matilda, would you call a radius a chord?
No, sir,
Why wouldn't you call a radius a chord?
because it's not touching the both side of the circle.
Okay, good. A radius is not a chord because it doesn't touch the circumference of the circle at 2 points, and the radius is expected to touch the circumference of the circle. And a chord rather is expected to touch the circumference of the circle at 2 points. That's why the diameter is a chord, but a specific type of chord. And you can see the actual chord itself, the general one. Okay, and now this is where this phenomenon where they say that the radius is half of the diameter. This is where it comes from. Just look at it here. When they say the radius is half of the diameter, you can actually see that the diameter cuts through the center and touches 2 points on the circumference. But the radius is just from 1 point on the circumference and stops at the center. So this is why they say that the radius, you have to times the radius by 2 to get a diameter. And if you want to get a diameter, you have to divide the diameter by 2 to get a radius. If you have a diameter and you want to get the radius, you have to divide that diameter by 2 to get the radius. That is because the radius is half of the diameter. You can see the illustration there. The radius is half of the diameter. So this is it for this part. Then we'll proceed to everything we're dealing with today are actually circles. So we'll proceed to something else still on this though. Now let us say that we have a circle as this is. Then we'll mark out the center as usual. That is in the center. Think here. Okay, so let's say we have a circle, we marked out the center there. Now, a chord which is not a diameter, that is just an ordinary chord which is not a diameter. Let's say the chord is here. So this is a chord which is not a diameter, as you can see. It's not a diameter, it doesn't pass through the center. When this chord cuts through the circle, remember, the body of the circle is called the circumference. But now see, when this chord cuts through this circle, when the chord cuts through this circle, you will see that it divides the circle, the circumference of the circle, into two different parts. When this chord, which is not a diameter, cuts through the circle, it will divide the body of the circle. I'm referring to the circumference as the body because I'm trying to use languages that would be easy for you to recall when you're solving, because this knowledge will help you when you're solving. When this chord, which is not a diameter, cuts through the circle, it will share the circumference of the circle into two different parts. Now, see one of the parts here. At the top, you see something like this. This isn't actually drawn to scale, but then you understand what I'm trying to say. At the top, you see something like this. At the bottom, you see something like this. So you see that the chord has shared this circle, the body of the circle, into two different parts, because when it cuts through it, then of course it will share the circumference of the circle into two parts. Now this is where an understanding has to come in. The body of the circle is called the circumference when everything is intact. The body of the circle is called the circumference of the circle when everything is intact. The whole circle is complete. That's when you call this the circumference of the circle, when you're looking for the sum of the whole parts there. But you see, the moment a chord cuts through this circle and divides this body of the circle into different parts, you no longer call this body of the circle a circumference. Instead, you now have to call this an arc. So now this changed from a circumference to an arc. No longer a circumference. These two, you call it an arc. So that is to say, the body of the circle is only referred to as the circumference, the total sum of the body there, which you call perimeter when you're looking at other shapes. So it's only called the circumference when it is fixed together, when it is whole as a circle. But the moment a chord cuts through it and tears that body into different parts, you know it ceases to be called the circumference. You can't say you're looking for the circumference of this as it is. What you then have to say is that this changes into an arc. Remember, the chord is not a diameter. Since it's not a diameter, meaning it's not passing through the center, therefore the two shapes you have now will not be equal, because you can see where the chord is. So the two shapes can't be equal. One is actually longer than the other. Now, when you have these two arcs, which has ceased from being referred to as, say, you're looking for a circumference because it has been divided. It's no longer whole. It's no longer together. When you have these two arcs this way, the bigger arc you see there, the one that is bigger, the longer one, is what's referred to as the major arc. The bigger one, you call it the major arc, while the smaller one, you call it the minor arc. When that chord divides the circle into two parts, as you can see, each part is now called an arc. The big arc or the longer arc is called the major arc. The smaller one is called the minor arc. Do you guys understand this? Golden, what about, okay. Melody, what about you? Christine, do you understand this? Okay, Melody, how about you? Not responsive. Winner. Okay, I think their network is glitchy over there. All right, so that's for that. So this is how you determine the major arc, the minor arc, and this is also how you get an arc. So once the circle isn't complete, the body ceases to be called a circumference. It changes into an arc. Once you have cut it, it changes into an arc. The bigger one is a major arc. The minor one is a minor arc. Okay, that being said, then we proceed. Now remember, this same chord, which is not a diameter, when it cuts through the circle, assuming we want to take the shape that it forms, not just only the body that was cut into two parts, because in this first part now, to get an arc, it was only the body that we took. So the body changes to an arc, major and minor arc. Now, what if we want to take the full shape that we have once this chord, which is not a diameter, cuts through that circle? What is the full shape, not just the curve? The curve is the arc, yes, but not just the curve, that full shape it will form. What if we want to take that? So let's try to look at this first. Remember, this is the figure we're looking at. So let's try to illustrate here that once the chord cuts the circle, if we have to take the full shape it will form, I think one is big like this. Okay, one would be big like this. And then you will see another one at the bottom would be a little bit would be smaller as it is. Now we're taking the shape, not just the what is it called? Not just the body, like the body, which is a curve, not just the body. The body is the arc. Now we're taking the full shape it will form, which is this. Get it from here. Let me call this let's call this A. So we're getting it from A there. Okay, now when that curve, when that chord cuts through the circle, if we have to take the full shape it will form, we'll have these two different shapes. One at the top, which you can see there, one at the bottom. It's just like when you're cutting an orange, when you cut an orange, something like that. So now one at the top, one at the bottom. Again, you will see that one is bigger than the other. One is bigger than the other. Now this full shape, please pay attention and listen to this. When you talk about only the body without taking the full shape it forms, when the cord cuts through it, when you talk about just the body, that's when you call it an arc. as you can see here. But now when you're talking about the full shape, that is both the arc and the chord together, that full shape it forms, not only the body, not only the curve. That full shape is now called a segment. This shape now is called a segment. So this is a segment. And this one at the bottom as well is also a segment. So both of them are segments. That means a segment is formed by an arc plus a chord. And a segment is formed by an arc plus a chord. Why? Because if you look at this, the body, the curve, it's no longer complete. So it's no longer a circumference. If you look at this body now, you see that, let me try to illustrate it here. The body now, you see that it is an arc. The body, you see it is an arc here. While if you look at this bottom, the straight horizontal line, you see that it is a chord. That means that a segment is the sum of an arc plus a chord, because this line that is cutting through the circle, this line here is a chord. So if you have to separate the shape, you would see that the segment is formed by an arc, which is the top, the curve you see there, and a chord, the straight horizontal line. That's what forms a segment. At the bottom, still the same thing, an arc and a chord, you can see there, forms what you refer to as the segment. Now again, look at this segment now. This segment still has a big one and a small one. One of the segments is big and the other segment is small. The one that is big, you now have to call it a major segment. These are compulsory WAEC and GCSE questions. Compulsory. WAEC for your theory, you see this, NECO as well. Even those of you that wrote JAMB, that wrote maths, I'm sure you must have seen this. GCSE, the same thing. Even when you go through a past question, you see it in your non-calculator. That's your paper one, you see it there, GCSE. So it's something that you need to know. If you have any challenge while we're studying this, please let us know here. Do not be quiet or be too shy to ask questions when you do not understand something. You let us know. You just raise your hand or unmute your mic and just say something so that we can, because there are recurring questions in these exams you're preparing for. Okay, so like I've said, the shape which is formed by an arc and a chord is referred to as a segment. And of course, again, you see that one of the segments is big while the other is small. Now, this segment that is big is referred to as the major segment. Who knows what name we should give to this other segment at the bottom? What should we give to this other segment at the bottom? Who answered that first question?
Minor segments.
Minor
Minor
segment.
Minor segments.
Thank you very much. Yes, thank you very much. Minor segment. So this other one at the bottom would now have to be called a minor segment. That is big one, major segment, small one, minor segment. If you are talking about only the body of the circle, big one, major arc, small one, minor arc. So remember, the body of the circle ceases to be referred to as a circumference when the circle is not complete together. Once anything is cut out, that body of the circle, that curve, changes to an arc, no longer a circumference. Okay, so now we've gotten an arc. We know what an arc is, major arc, minor arc. We proceeded to a segment. Now we know what a segment is, major segment, minor segment. Oh, I think so. So now we will continue with what we're doing. There was a glitch in the network. I think there was a glitch in the network. So back to this. Can you guys see the board? Okay, all right. My network glitched just now. All right, thank you. I hear you. Okay, so that being said, you see it's still even loading. So that being said, we will now move to a sector, because there are three major parts: an arc, a segment, and a sector. So now we'll move to a sector and see what a sector is, try to see what a sector is. So again, we're still taking a circle. So you have to take a circle and say, okay, let's try to mark out the center of the circle first. Let's say this is the center of the circle. And then when you have a chord which is not a diameter, let's say this is a chord which is not a diameter, then you have the radius of the circle. Remember, the radius is any line that touches only one part of the circumference, that's of the body of the circle, and stops at the middle, at the center of the circle. So let's say from here to here, that's the radius. And also from here to here, that's the radius as well. So these two parts, this is a radius. This too is a radius, because obviously you can see that it's coming from the body of the circle and stopped at the center. The other part too is still coming from the body of the circle and stops at the center. So both of them are radius. Now let's look at this. What happens? I think I have to
Sir, please come.
remove this.
Please, this illustration, like my network was blank. I don't know what you did here.
Which parts?
This
This
last
one that
part.
had radius.
Yes,
This
sir.
one with the radius twice.
Yes,
Okay,
sir.
all right. All right, no problem. All right. So now we are looking at this. We say that when two radius, that's we call it the plural, that's a radii. When two radii cuts through your circle, when two radii cuts through your circle, you have something like this. So both of them are radius individually, because a radius has to come from one point on the body of the circle and stops at the center. So you can see the first one coming from one point at the circle and stops at the center. The other one, the same thing, one point of the body of the circle stops at the center. So both of them are radiuses. So we call them radii as plural. When you're talking about one radius, you say it's a radii. Now, this type of shape you have now, if you want to cut it out, the shape, not only the body of the circle is an arc, I've talked about it. The shape itself, when these two radii cuts through the circle, that shape it forms this, this is mostly associated with pizza. You see, most of the time when those pizzas you buy, it's actually a sector. I'll show it to you here. That those pizzas, when you cut through it and about it in them, most of the time, I think all the time, not even most, all the time, they happen to be sectors. You'll see what happens when these two radii cut through the circle. Now let's try to form the two shapes that you will have. You have the first shape as something like this to be big. This is the center here. This comes here. Not drawn to scale. I'm just trying to, So this is the top one. You see that top one there? That's the top one. Then at the bottom, you see another one. At the bottom, you see another one, maybe something like this. When you share this diagram here that we have here, when you share it into two, from the way the radii cuts through it, the one at the top, look at the shape, the one at the top will look like something as illustrated there. Then the one at the bottom will look like this other one I illustrated at the bottom. Do you agree? Okay. All right. So now this shape that is formed when two radii cuts through your circle, this shape that is formed when radii, that's two radii, cuts through your circle, this shape is called a sector. This shape that is formed when two radii cuts through your circle, this shape is called a sector. So you see that top one is a sector. This bottom one is also a sector. What forms a sector? The sector is formed by radius plus arc. How did I get it? Radius plus arc. That is 2 radius plus arc. That's what forms a sector. It's just like a segment. A segment is, oh, it's gone. For the segment, we said it's arc plus chord that forms the segment. And we said this is major segment, while this other one is minor segment. And if you look at this shape, it's formed by arc plus chord. Now look at this other one, a sector, when two radii cuts through it. When two radii cuts through the circle, gives you a sector. You see the top one is a sector. Radius, arc. Where are the radius, arc? Here is a radius. This is a radius. The body is an arc. The same thing as this bottom. The bottom one, radius. The body, arc, that's the curve there, is an arc. That means a sector is formed by radius plus another radius plus the curve, which is an arc. Do you guys understand this? What about the others? Lucas, Winner, Melody. Okay, Christian said she understand. Golden understand. Lucas, do you understand that? Efosa, yes, I see you. Okay, Matilda, do you understand this? Okay. Winner, do you understand? All right. So back to this. So that's what forms a sector. A sector is formed by radius, that makes it 2 radius, plus the body, which is an arc. That's 2 radius plus arc forms a sector. So again, look at this. You will see that one sector is bigger than the other. One sector is bigger than the other. The bigger sector, again, you call it the major sector. The smaller sector, you call it the minor sector. So remember the difference here. One, an arc has a major arc and a minor arc. The arc has to do with only the body when it has been split, when the circle is no longer complete, only the body, that's an arc. A segment has major and minor as well, but the segment has to do with both the combination of the arc and the chord that chord sits. Combination of arc plus chord gives you a segment. Then there's a major and minor. Then you go to a sector. A sector is formed when two radii cross through the circle, when two radii cross through the circle there. So you see the one at the top and then a smaller one at the bottom, something like the pizzas. And most times that people, when they buy it and cut through it. Now, this sector is formed by two radii, that is radius, plus the body, the curve, which is an arc. That gives you two radius plus arc. So this is the introduction of the basics you need to know in a circle. Now we are starting calculations. So now we're going to calculations. First, we will take this question and see the different formulas we are to use. First of all, length of an arc. If you're told to calculate the length of an arc, which is the body of the circle when it has been cut, the formula is theta over 360 times 2 pi r. This is the formula if you are told to find the length of an arc. The formula you would be using is theta over 360 times 2 pi r. Remember, I told you this is a recurring question in the exams you're preparing for. This is for those of you here in Nigeria. This was taught to you in SS1 and revised with you by your teachers in SS3. While for those that are in the UK, this was taught to you in year 10 and revised by your teachers when you got to year 11 and also year 12 as well. So if you have any challenge at all, please let us know so that we can trash that out. So now the length of an arc would be theta over 360 is 2 pi r. Then if you're looking for the length of a chord, the length of a chord is 2r sine theta over 2. This is the formula for the length of a chord. 2r sine theta over 2. So I think these are the two things we dwell on today. Then for the segments and sectors, those are very simple. Once you're able to identify what the length of an arc is and the length of the chord, then to get the perimeters, that's very simple. So perimeter is something that won't take our time at all. So let's look at how to determine the length of an arc and length of a chord. So please take note of these formulas. Length of an arc, theta over 360 times 2 pi r, where theta is the angle. Theta stands for the angle and r stands for the radius. Pi is already constant, 3.142 or 22 over 7, whichever the instruction in the question asks you to use. Okay, so a quick question here. Oh, no, not this. Okay, so center of the circle Center of the circle. Whose mic is on? Someone's mic is on. Let's say this is 60 degrees. Okay. So now let's give a radius. Let's say radius is 7. Okay, so we have this question now. 7 centimeter as a radius, while the angle subtended by the chord at the center of the circle is 60 degrees. Now remember, this is the reason we're introducing the meaning of those different things, so that when you're dealing with them, an actual question, you know what each of those lines stands for. So that 7 centimeter you see there is the radius of the circle. This straight line this horizontal line at the bottom, that is a chord. Then what else? The 60 degrees there, that is a theta subtended by the chord at the center of the circle. Now, first question, let us say determine one, length of minor arc. 2, length of major arc. 3, length of the chord. I think let's deal with this first. So this is our question. First question, find the length of the minor arc. Now remember, there are two different arcs here when that chord cuts through that circle. Let's call the chord, let's say PQ. There are two different arcs when the chord cuts through the circle. Now, I will try to mark this, and I'll need someone to tell me when they say find the length of the minor arc. I'll need someone to tell me where we're looking for. So I want to mark with colors. And then someone will tell us what we're looking for. So this, I'll mark with purple. Mark with purple here. Okay. So find the length of the minor arc. Please someone tell us, is it the minor arc we're looking for, is it the red arrow or the purple arrow?
The red arrow.
Okay, good. The red arrow. The red arrow is a smaller arc, so it is a minor arc. Now, I ask another question. Okay, no, I don't think I should because we haven't done anything about that. So now we're looking for the length of the minor arc. Remember that length of arc, length of arc is equals to theta over 360 times 2 pi r. That's the length of the arc. Now, when you're dealing with this, your minor arc, go number one, you're looking for the minor arc, which is that where the purple arrow is illustrating. The red arrow I meant is illustrating. Now, the theta you will be using is 60 degrees. Why? Because the 60 degrees is the angle subtended, as you can see there. How should I say this? The angle facing the minor arc is 60 degrees. You can see the 60 degrees here. The 60 degrees is facing the minor arc. So the angle you're using when you're looking for the minor arc is 60 degrees. That is your theta. So now we'll come back here and then try to solve. Our theta is 60 when we're looking for the minor arc. So here we can say that the length of minor arc is 60 over 360 times 2 times pi 3.142 times radius is 7. You can see there the radius is 7. Now someone should help us multiply everything at the top, divide by 360 at the bottom. Someone help us with that. 60 times 2 times 3.142 times 7 divide by 360.
Sir, please, how do you get this 3.1?
Pi is 22 over 7. 22 over 7, that's 3.142. Do you understand? Does everyone understand what we're doing? Okay. All right. What about the person that asked the question just now? I couldn't catch the person's name. Who asked that question just now?
Matilda.
Okay, Matilda, do you understand how we got the 3.142 now? It's 20 pi is 22 over 7.
Yes.
Okay, so pi is 22 over 7. If you like, you can use 22 over 7. It doesn't matter. It's just the value for pi. 22 over 7 gives you 3.142. All right, so someone please tell us the final answer for minor arc. Someone tell us the final answer for minor arc.
7.331.
Okay, let's do 7.3 centimeters to 1 decimal place. So the minor arc is 7.3 centimeter. That's the minor arc. Now we're going to number 2. Number 2 would now be the major arc. That's number 2, major arc. So let's come to this now. The major arc, what arrow signifies the major arc, red or purple?
Purple.
Okay, good. Purple signifies the major arc. Now look at this major arc. Look at this diagram. Look at this major arc. There is no angle for the major arc that we have there already written. That 60 degrees was for the minor arc. A simple way I can use it's not mathematical, it's not a mathematical language, but it's best for students to understand. A simple way you can understand this is that the angle that belongs to that arc is supposed to be facing the arc. If you look at our minor arc now, the angle that belongs to the minor arc, 60 degrees, was facing the minor arc. But now look at your major arc. There is no angle that is facing the major arc. That 60 degrees does not belong to the major arc. The 60 degrees belongs to the minor arc because it is facing the minor arc. Now you will need to find the angle that belongs to the major arc because you don't have it there. So you need to find it. And the angle that belongs to the major arc is supposed to, please look at what I want to draw with green. Look for green on the diagram. The angle for the major arc is supposed to be at the top here, facing your major arc. That is that angle I drew with green. It's supposed to be at the top, facing your major arc. But as it is now, you don't have any angle facing your major arc. So what then do we do? But we know that the sum of angles at the center, the total sum of angles at the center of the circle is 360 degrees. That's angles at a point, or the sum of the center and the reflex angle. That gives you 360 degrees. That means if this angle facing the minor arc is 60 degrees, then the reflex angle, the one that should be at the top, that green, should be 300 degrees, because that's what will make it complete 360, because that full place at the center, the full total angle should be 360. So if this other one is 60 for the minor, then the balance to complete it 360 is 300. That means the angle that we should use for the major arc should be facing the major arc, and the angle that should face the major arc should be 300 degrees, so that it will complete 360. Do you guys understand this? Okay. Golden, Melody, Matilda, do you understand this? Okay. Matilda, what about you? Okay, no response there. Winner.
Sir, I put a thumbs up.
Okay, all right. Okay. I guess it was part of the screen covers that, so I didn't see it. All right, so that's fine. So like I've said, the angle that should be used for the major arc is supposed to be facing the major arc, and now we don't have any angle facing the major arc, so we have to look for it for ourselves by ourselves, and that will be the reflex angle that will complete that full angle at the center to be 360, and that balance that will complete it to be 360 should be 300. That means the angle that should be at the green, that should face the major arc, is 300. This now means that if we are looking for the major arc, our theta is no longer 60 degrees. Our theta will now be 300 degrees. So for number 2, major arc, length of major arc for number 2. Can I clean this here? Okay. Number 2, length of major arc, length of a major arc. It's still same formula, theta over 360 times 2 pi r. And then if you have the theta over 360 times 2 pi r, our theta is now 300. So major arc now have 300 here over 360 times 2 times 3.142 times the radius, which is 7, so times 7. So that would be a major arc. So someone please help us with the final answer there. 300 times 3 times 2 times 3.142 times 7.
36.65.
36.65. So our major arc is 36.7 centimeters. Because we left the minor arc as in 1 decimal place, so we have to leave the major arc in 1 decimal place as well. So that 36.65, we're leaving it as 36.7 centimeter. So actually, you would see that this is correct. Why? Because the minor arc is the smaller one. That's the red. You can see the red there is a minor arc, is the smaller one. The major arc is the longer one. So actually, if you see your minor arc, it's 7.3 centimeters, is a smaller length. And if you see your major arc is 36.7 centimeters, so it's actually bigger. So that is to say, if you solve a question and your answer for minor arc is bigger than your answer for major arc, you already know that you've made a mistake, because there is no way minor should be bigger than major. So take notes of how to get the angle for each of them, minor and major. If they give you the angle for major, when you're looking for minor, don't use that same angle. You have to subtract from 360 to get the angle that should be for major, for the minor. They give you the angle for minor. When you're looking for major, do not use that same angle. You have to subtract from 360 again to get the angle that should belong there. So this is for number one, length of an arc. We should say the formula is theta over 360 times 2 pi r. Length has to do with major arc and minor arc. Then lastly, the last question we have here is the length of the chord. The length of the chord. So we say that the length of the chord is 2r, that's number 3. So the length of chord is 2r sine theta over 2. Now, before we proceed to look for the length of the chord, I want to ask a question. I'll go back to the diagram. We already know what the chord is from what we looked at here at the beginning. We can identify a chord. You see it there. That's the chord. Okay, now I'm going back to this question. Look at this chord in this diagram. Do you think that a chord has minor chord and major chord? Do you think a chord? Please, I'll ask you, I'll direct the questions to you. Just look at the question first and I'll get to you. This is the chord here. Do you think a chord would be having major and minor? Christine hasn't answered the question in the class. Christine, do you think a chord should have major chord and minor chord?
No, sir.
Okay, let's come to someone else. Lucas, did you look? Okay, no, Lucas. I think Lucas answered the question. All right, don't worry. Let's just Lucas. Do you think a chord should have major or minor chord?
No, sir.
Matilda, what do you think? Should a chord have major or minor?
No, sir.
Golding, do you agree with these answers that a chord shouldn't have major or minor?
Yes, sir.
Okay, Melody hasn't been responsive. Melody and Winner, so I don't need to ask them. Efosa, a chord, should it have major or minor? Efosa, okay, not responsive. Okay, so Golding, I'm directing this question to you now. Why shouldn't this chord have major or minor? Why shouldn't a chord have major or minor?
Because a chord is a line that divides a circle.
So when the chord divides the circle, so it doesn't change like the others that gets big or small. It retains
Yes,
its
sir.
original, whether major or minor, whether you're looking at it from the top or from the bottom, the chord retains its length. Is that correct?
Yes.
Okay, good. So as long as the chord retains its length, then a chord does not have major chord or minor chord. A chord is a chord. Now we want to look at the length of this chord. It says the formula is 2r sine theta over 2. The length of this chord formula is 2r sine theta over 2. So again, I am directing a question to, I will call someone who would answer the question, but just look at this formula, length of chord, 2r sine theta over 2. Now I'm going back to the question. Look at that diagram very well. I told you how to identify the angle you should use when you're looking for certain things. I used a simple statement. It is not actually a mathematical statement, but it is a statement that should make you always get it correctly. I used the statement how you can identify the angle that belongs to that particular thing you're looking for. That's the correct angle to use when you want to calculate. I said the angle must. Okay, let me end there. Now, I'm directing my question to Efosa. I'm directing my question to Efosa. Efosa, which angle between the 300 degrees and the 60 degrees? Look at the diagram, Efosa. Which angle between 300 degrees and 60 degrees? Which angle should we use when we are looking for the length of the chord? Efosa, this is a question. Which angle should we use between 300 degrees and 60 degrees when we are looking for the length of the chord? Okay, no response from Efosa. We will direct the question to Lucas. The mic is on. We'll direct the question to I think almost everybody has answered the question actually. But then we don't have a choice. We just have to okay. Matilda.
Sir?
Matilda, okay, I'm going to the diagram. We're looking for the length of the chord. That's the last question, length of the chord. Which angle should we use to look for the length of the chord? 300 or 60 degrees? Did you get the question?
Come again, sir.
We are at number 3 now, length of the chord, length of the chord. So I am asking, what angle, look at the length of the chord, look at the formula. The formula for length of the chord is 2r sine theta over 2. 2r sine theta over 2. So that theta stands for an angle, as you're aware. Which angle should we use there when we're looking for the length of the chord? Because now we have two angles. One was 300, one was 60 degrees. When we're looking for major and minor arc, one was 300, one was 60 degrees. So I'm asking, what angle should we use between the 360 and the 60 degrees when we're looking for the length of a chord? Look at the diagram there.
60 degree.
Why? Why do you think so?
Because it's from the 60 degree that touches the circumference of the angle.
The circumference of the angle.
Of the circle.
Okay. All right. So it's actually 60 degrees. But that explanation is, I understand what you're trying to say, yes. So it's actually 60 degrees. So remember, a simple way of knowing the correct angle to use is the angle to use must be facing that thing that you're looking for. So it is 60 degrees that is facing the chord that you're looking for. Look at the 60 degrees. It's facing the chord you're looking for. So it means that it is 60 degrees that you use. But a mathematical statement is that the chord subtends an angle of 60 degrees at the center of the circle. But then a simple way, non-mathematical method of knowing is just look for that angle that is facing the chord, or if it's an arc, whatever you're looking for, what angle is facing it. That's the angle you should use. If there's no angle facing it, you have to make subtractions to get the angle that must have to face it. So here the angle we're using is 60 degrees because 60 degrees is what is facing the chord. That makes the length of the chord to be the length of the chord now becomes 2 times arrow. The arrow is 7, that's radius. 2 times 7 times sine theta is 60 over 2. That's 2r sine theta over 2. So we're using 60 degrees. So 2 times 7, which is the r, times sine 60 over 2. Progressing, we have 2 times 7 is 14 times sine 60 divided by 2 is 30. So sine 30. Sine 30 would be sine 30 would be 0.5. So this is now 14 times 0.5 because that's the value for sine 30. So 14 times 0.5 and 14 times 0.5 would be 7. So the length of these the length of the chord is 7 centimeters. The length of the chord is 7 centimeters. Does everybody understand this? How we got I'm coming. Does everybody understand how we got this result, 7 centimeters? Okay, we not okay. All right, Christine, Golden, Lucas,
Please
what
explain
about?
the last part again.
Okay, all right, I will. Lucas, what about you? Winner, you've not been responsive and you're giving a thumbs up. Are you sure you understand that?
How that sound?
Why have you not been responsive in the class?
Before I will respond, network will be already the this thing.
Oh, okay, all right. Okay, so that's by the way. Then Matilda, okay, the length of the chord is the formula is 2r sine theta over 2. Then we said 2 times 7 times theta is 60. It was even you that said the theta should be 60, which is correct. So 60 over 2. Now 2 times 7 is 14 times sine 60 divided by 2 is 30. So times sine 30. And 14 times sine 30 is 0.5 when you use your calculator. Sine 30 is 0.5. So then you have 14 times that's 0.5 and the result is 7 centimeters. Do you understand this now, Matilda?
Yes, sir.
Okay, so basically this is all you do when this is just the beginning part of the circle geometry. So this is actually the majoration part of it. So next time when we meet, we'll look at perimeter of sectors because now we just dealt with arc and chord, just the length. Next time, look at perimeter of sectors, perimeter of segment. Those are very simple. You just have to add the sides of the sides, the length of the sides that forms the sector. You have the length of the sector. Length of the sides that forms the segment. You have the perimeter of the segment. So that's very simple. After knowing the length of the chord and length of the arc, those other ones are very simple to deal with. So we will not be able to take individual questions here because it's almost time, but I'll quickly rush to the beginning of this and try to take a quick sweep of it for some persons that were not early enough. So first off, we said that any line segment that can touch the body of a circle, which the circumference of the circle at 2 points, touch the circle at 2 points on each circumference, that line is called a circumference, a chord rather, but the line has to touch 2 points on the circumference. You call it a chord. Then we said a diameter is a particular type of chord that passes through the center of the circle. You can see that the diameter is also touching 2 parts, but it's passing through the center of the circle. We then proceeded to a radius, and we looked at why a radius is half of a diameter and why a diameter is twice the radius, because the radius touches only one part of the circumference but stops at the center. It stops at the center, it doesn't go beyond the center. But the diameter passes through the center and touches the other side. So the diameter is like a full one, dividing the circle into 2 parts. But the radius, from this illustration, you see that the radius is half of the diameter. Okay. Then we said again that when a chord, which is not a diameter, in this diagram labeled A, when the chord, which is not a diameter, cuts through a circle, the circumference of the circle, if we have to separate them, you see that one part is big, the other part is small, and it ceases to be called a circumference because when you separate them, it's no longer a circumference, because a circumference, the word circumference is only used when the circle is whole, when it is completely a circle together. But by the time you're sharing them, the body, you have shared the body, like this illustration with the blue arrows there, you can see that the circle wasn't like complete anymore. It's been separated. Now, the bigger one, that body is now called an arc, no longer a circumference once you cut it. The bigger one, you will call it a major arc. The smaller one, you call it a minor arc. Those are the blue arrows showing you there. Then we proceeded to say, if we don't take only the body, which is the arc, the body that has been separated, which is the arc. If we don't want to take only the body, I want to take both the arc and the chord that goes through it. We said that means we'll now call that shape you will have a segment. The big one is a major segment. The small one is a minor segment as well. Then we went on to say that a segment will therefore be formed by an arc and a chord. The arc, which is the curve, the body that has been the curve, plus the chord, which is our straight horizontal line at the bottom. Then we went also to a sector. We said the sector is formed by 2 radii, that's radius and another radius. You see the illustration there, and an arc. So a radius plus an arc forms a sector. And we looked at that when the 2 radii cut through the circle and you have to separate them. When you separate them, you see something like a pizza shape. That's the one you see there, those 2 diagrams there by the right. We said the bigger one is a major sector. The smaller one is a minor sector. And do not forget that the sector has to be formed by 2 radii and an arc. So a sector is formed by radius plus an arc. And radius plus radius is 2 radius plus an arc. That gives you that. Then we proceeded to this last part, to the calculation part, where we said the length of an arc is theta over 360 times 2 pi r, while the length of a chord is 2r sine theta over 2. And when we're looking for the length of this question, the length of the minor arc, we said the length of the minor arc, we already know the formula as theta over 360 times 2 pi r. And the theta we used for the minor arc was 60 degrees, because obviously, as you can see, that 60 degrees was facing the minor arc. So we used 60 degrees to solve that, and then we did the rest. But when we go to the major arc is the bigger one at the bottom, at the top rather, the major arc wasn't having an angle on the diagram there. The major arc was supposed to have an angle that should be facing it, but obviously, as you can see, there is no angle that is facing the major arc that we should use to calculate it. That's why we labeled that part green. That's the angle at the top there, green. So we now have to look for what angle will be facing this major arc. So when we add those two angles at the center, we're supposed to have 360. Now, if the one for the minor arc was 60, that means the balance to complete the 360 would be 300. That's why when we're looking for the major arc, we now use 300. We no longer use that 60. We now use 300. So you see it here for major arc, you see that we're using 300. Then lastly, we went to the length of the chord, which is given as 2r sine theta over 2. We discussed about what theta to use. Is it a 60 degrees or is it a 300 degrees? And then we came at a conclusion that it should be the 60 degrees because the 60 degrees is the angle suspended by the chord at the center of the circle, or a non-mathematical statement would be because 60 degree is the angle that is facing that chord you're looking for. Remember, the angle that faces what you're looking for is the angle you should use. If no angle is facing it, you have to make a subtraction to get that angle, or depends on how the question is. You have to get that angle that should face it. The angle you must use to calculate the length of arc, length of chord, or whatever, make sure that angle is facing that thing you are looking for. So that was what we did there. We decided that it was 60 because 60 was facing the chord we're looking for. You already know what the chord is there. Then we did that, did the math, and 60 over 2, just the whole of it there. And then we got 7 centimeter as the length of the chord. So this is all we did today. And then I think next time we'll be able to go further than this and get into the what is it called, the actual circle theorem. So these are the mensuration part of it. So do you guys understand all that we've done today? Okay. All right. So I think then it's safe for us to say we can end the class here. Until next time, do take care of yourself and have a good night rest. Bye.
Thank you, sir.
All right. Bye, everyone.
About me, what's up? Good evening.